Hi, my name's Andy Colthorpe. I'm a journalist with PV Tech. While the cost of solar panels is falling and their efficiency increasing, and as we hopefully move towards a subsidy-free future, it's what your inverter and other power electronics can do that really defines your PV system and how it interacts with the grid and the rest of the world. We spoke to 3 of the leading inverter manufacturers to see what they're offering to the market now in Europe and beyond. But first, let's have a quick primer on inverters and how they're changing with PV Tech Senior News Editor Mark Osborne. So Mark, can you tell us a little bit about how the inverter market is transforming and how the role of the inverter itself is changing?
Well, I think the first thing you've got to remember is that the inverter is the brains of the system. And in many respects, it's getting cleverer and cleverer. And there's a couple of key reasons for that. One is that the demands on what the inverter does for the overall system is changing. So that's becoming more challenging. You've also got the addition of different needs and requirements, whether it's self-consumption or things like battery storage or energy storage systems. And I think overall, you're going to see in the future then integrating that with electric vehicles. And it's being able to see the future of what an inverter really does instead of simply transferring direct current to alternating current. It's going to be a much cleverer object, and therefore that's why the market is changing very, very quickly towards meeting these needs.
The inverter has an important role in terms of grid management, so he can integrate the PV installation on a smart way into the grid, and he can also manage the energy consumption on a smart way at the house. So we can do both. We can do smart houses and we can do smart grids, and this is the connection in between the inverter. So it's more or less the heart for doing that.
All of our inverters can now interface with the consumption meters, read them, and you basically as a system owner and as a, let's say, a factory owner or a home owner, you actually see your self-consumption rate and you can better behave in terms of your consumption. We add to that a new feature that we are showing here, which is called feed-in limitation. This is a feature that was initially developed for the German market in order to comply with the 70% feed-in limit rule. Right. But what we found is that in many markets in the world, in UK, in Netherlands, in Australia, all across Europe, and even in United States in some places, PV systems are being denied because of grid conditions. In places where there is high PV concentration, you sometimes cannot install a PV system because the utility company is afraid of too much feed-in.
We looked for an integrated solution because we wanted to have easy handling.
Sure.
We looked for an integrated solution because we didn't want people to do some engineering at home. We wanted people to use it as it was a PV inverter, but to increase their self-consumption.
We have inverters from 2 kilowatt residential part up to the megawatt part. And here in the background we see the corner with the residential inverters, so it's P series, starting at 2 to 5 kilowatt single phase with advanced features, especially for self-consumption. Self-consumption is a very important topic for Europe. Feed-in tariffs get less and less. Absolutely. And so it's important to improve this feature, and it's integrated in the inverter. So there's basically, we call it micro EMS included, and so you can basically make your home a little bit smarter and switch on loads when sun is ready.
So you mentioned self-consumption and storage. We still seem to be a little bit of a way off. PV systems come with batteries as standard, but what are some of the companies that we're looking at really kind of doing to get themselves ready for this sort of future of solar?
Well, I think a key thing, especially from a self-consumption point of view, you've got to engage with the consumer, so the information that is displayed from the inverter is going to be very important, because if self-consumption does allow you that 70% or maybe more, you've really got to be intelligent and understand where you're using that consumption, and the inverter is a very good place to tell you. So whether then you can have that linked to a computer or a smartphone, all the apps start to open up because the data is then accessed for the consumer, whereas historically it's really data for the grid. It's the data for the electricity utility or whoever you're using, and not really of any use or any value to the consumer.
It's an I/O board, input-output board, where you can connect an energy meter. So the inverter knows what you are exporting to the grid, and depending on this value, you can decide if a load should be switched on and off. So you can you can increase the share of your self-consumption. This is a cheap and easy solution, which should be standard in some countries. Here we see this I/O model for the improvement of self-consumption. This is an option in this inverter, and so you can buy it later as well, and therefore improve self-consumption or do this 70% limitation in Germany, for example. The monitoring system is here, MaxView is included. We send values every 15 minutes to a web portal, and so you can later see it on your iPhone or a pad, tablet, and have basically a free of charge monitoring system included. Yeah?
Okay.
No data logger anymore required. We believe that data loggers are too expensive for such small plants. The other idea is about storage. So if you want further increase your share of self-consumption, then you need basically a storage solution. So we call that P-battery. So this is an upgrade kit for the P-series. And so you can retrofit existing P-series inverter with this option.
With storage, seems like we're still a little bit of a way off before that becomes kind of an accepted part of the market, but...
Well, there's another factor. In some respects, if you want to be really cruel about it, it's a product looking for a market. But actually, when we see costs come down, when we see better integrated systems, which again help reduce costs, but also, of course, it's the form factor. These are quite bulky, objects. So there's a whole route, a whole development curve has to go on that basically becomes more attractive for the consumer to actually adopt. And in that sense, again, the use of the battery, the understanding of what the battery can give through then, a graphic user interface that's consumer friendly. All of these things are going to be required, and we're just at the early stages of seeing that happen.
This, what we are showing here, is our new storage unit. Storage is basically a battery pack from SolarEdge that comes built in with the electronics and battery inside. Every pack is 2.5 kilowatt hours of storage. You can put them in parallel to get more storage if you need. And storage, together with feed-in limitation, actually increases your level of self-consumption by storing unnecessary PV energy and then using it either at night or at times where the PV is not enough. Currently, with the price of batteries, I don't think that without some level of incentive, it is economical. But PV was that for many years. So as the battery prices are reducing, and you see that the battery industry is showing very, very nice learning curve, and that battery prices are expected to cut down by almost half in the coming 10 years. So as battery prices are reducing, this will be the natural part of every PV system.
The business model of a storage is always the gap between production costs and electricity rates. So if the gap is big enough, you can pay a storage. At the moment it's close to it, but you have to consider some increase of the electricity rates, but which are coming year by year.
Yeah, because the electricity rates don't tend to go down,
no,
really, do
they are increasing every year, and it's even stronger through the last years. And that's one reason why to think about storage. At the moment, if you look at the situation in Europe, there are some regulatory hurdles. So a grid operator is not allowed to operate a storage.
Right, yeah.
Somebody who's selling energy can operate a storage, but he's got no interest in grid stability. So there we need some political help to make that happen.
Storage has already had a fairly firm business case for use in off-grid and latterly in replacing diesel gensets in things like mining operations?
Well, people forget that off-grid has been around for a very long time, and a lot of the knowledge that's there with inverters for running off-grid and mini-grids is really going to helping the industry then adopt those kind of systems and safety features for self-consumption and for residential. And what the key thing there is that they've been more industrial. Hybrid, off-grid systems have been more industrial in their nature, and we need a much more simpler, subtler system for self-consumption. But I think what you will have is that the storage side makes total sense to both residential and commercial, and therefore the knowledge from the off-grid is going to be very useful for that.
We needed a standardized and open, a modular solution which we could put in any application. The market was very small at that time, dedicated to off-grid solutions, to remote islands, remote places, even in the mountains or wherever. And we needed something that an installer could adapt easily to the needs of these remote locations, meaning that you have to charge and discharge with different sources, like wind and PV and a diesel maybe. Yeah. We have to adapt it to different system sizes, from very small to slightly big to very big. We have to adapt it to different temperatures, like Africa, or we have one system in the Andes in Chile, one system on the South Pole, close to the South Pole in the Antarctica. So cold and warm, all of them very, very flexible. Different batteries and all of that. Through the time, the systems are coming closer to the grid. Means that you need more standardized solutions, easier access. The PV installations, they are now, let's say, a commodity. If you want to have a PV system on your rooftop in Germany, you just call an installer, ask him, I need a PV system. You just ask one question: what is the size of your roof? Sure. So that's quite easy. You say 40 square meters, and then he gives you a quotation, and you can buy, and he will install. If you want to add a battery to that, the first thing you have to take into consideration is make it easy. The setup of the households in one market is very, very similar. So you need to just analyze the load profile, the irradiation, and then you find out what is the specific demand. So if there is self-consumption, captive power in the household, you want to increase that. How to do that? Store the energy when it's produced but not needed, the surplus into the battery, and then discharge during the evening hours, maybe to evening peak or even through the nighttime.
The main challenge with storage solutions is finding the right battery vendors that you can work with and finding the right architecture. Because we have power optimizers in our inverter systems, we wanted to find an architecture that sits well with our power optimizers. And what we found is that because we have power optimizers and we have our fixed ring voltage solution, if we do the same with batteries, we actually give the installer a huge advantage. The installation of this is very easy. You just plug it parallel to the PV. Don't need special knowledge. Any PV installer can do it with pretty much minimal training. And that is actually something that, because we had optimizers, we could also do in our battery.
Here, this is the P battery. I mentioned that to retrofit the battery system. And here you see how easy it is. So it's really just this ring. You receive the inverter just like this with the cover. And if you want to retrofit it later, you buy this unit. And the installer is retrofitting it on site. And so you can connect the battery, which we see here behind, and increase self-consumption even more.
So how does an inverter manufacturer counter the differing technical standards and needs of different markets, as well as other aspects like safety?
You do some sort of a failure impact analysis and just check what can happen. Breaking lines, interrupting communication, short-circuiting by some sort of material failures. And then you analyze what can happen, what will happen, and what is the countermeasure on that. Writing that all down, checking. Then going to an institute, that's what we did. We went to the VDE asked them for a certification of the system, not of the battery. We didn't want a certified battery. That's what we asked from our supplier.
Okay.
Give us a certified battery.
Yeah.
First step of safety, but then integrate it into a system and then certify the system. Ask for any possible failure that can happen and make it safe.
All of these specs are what is called KFW compliant. So they meet all the necessary regulation in terms of open protocol for communication, means and ways to extend the battery life and to replace batteries. Yes, they are all KFW compliant. It's actually a smart subsidy mechanism which verifies that the product is suitable and will also give the let's say enough self-consumption benefit to the homeowner or the system owner.
In the US we have UL certification. This is quite tough certification, which is quite different to the European certification. So you basically have to change many components that you are able to get certification for the US. And of course you have different voltages. Yeah. So in the US we do not have this 230 and 400 volts like here in Europe. Yeah. And so it's not just a certification issue, it's also different voltages and therefore, let's say, different components at the end.
Okay, so this must be something you really have to consider when you're looking at different kinds of markets like this.
Yeah, so really within Europe it's quite easy to go abroad, but if you go to the US it's really a significant step and you need time and money to do that. Yeah.
So we've managed to have a very brief look at what's going on with inverters today. We hope you found it informative. You can find a lot more detailed technical information, a lot more information on policy, and a lot more information on the industry in the pages of our website, PV Tech. Thanks very much for watching.